Okay, I want to go over this multi-channel funding plugin. Last time I gave an introduction to the G Lightning plugin system, and so hopefully some of this will be familiar to you. But let's get started up here with the RPC. Is basically implementing the functions that at the time I did this were not in G Lightning. She since has added the fund channel start and the fund channel complete, and so I'll have to migrate over to that. But that's pretty much all that's here. There's still the list configs, which I talked about last time. I did not see that being put into G Lightning, so that's the RPC. You can see the structure on the left. We have a wallet where we go through the different implementations in the interface and the basic plugin stuff. So next up will be this multi-fund, which is similar to what we showed you last time. It's the plugin architecture, and it sets everything up very similar to what we already showed you. The difference here is we do actually have an option, and we're registering 3 methods. So the option is what kind of wallet do I want to use. This will work with both the Bitcoin Core node and your internal C Lightning node. I originally had some plans, and I may still go that way. I kind of am showing you an older version of this code. I refactored it out to where you can do some external, which would be good for communicating to a server, and doing a multi-party is what I'm working towards. But I wanted to keep it simple for this video, so I wound it back to an earlier version. This is pretty much what you saw working in the video where I did the demonstration of this. So anyway, we do have the option to tell you which wallet to use, and we have 3 methods. We can open multiple channels, and with a single transaction, we can connect to the nodes and open multiple channels. And I also added a withdrawal method, which is basically the same process as opening channels, but much simpler. So it just kind of made sense to throw that in there too. There was some requests, open issues on GitHub about it, so I figured I'd throw it in this plugin too. But basically, it's registering the methods, new RPC methods based on some different data types like we talked about before. So I guess the next thing would be to look at those data types. Go to our fund, and that's where we set up our multi-channel. That is what we pass through when we register it. You can see when we're in the name function, we return a fund multi, so that's going to be our RPC command we use. This similar like I showed you last time. And then we have a connect and fund request, which, let's look at the code. We have a connect and create multi, which loops through all the nodes and connects, and then calls this create multi. So we come back up here, we have the create multi here in the call, and connect and create multi. So we're reusing this create multi for both, because it's the same process, but the connect, we can throw that in there beforehand. So that's what we have here. The connect is pretty straightforward. You're just looping through. You're calling the Lightning RPC, which will create the connections for you. I don't think I need to go into much detail there. That's pretty straightforward. Just RPC response, and once you get that, you call your call your create multi. So the create multi is the bread and butter. Like I told you last time, bread and butter is from the call, and it's pointing to create multi. So if we take a look at that, what do we have? We have our fund channel request that automatically is populated by what you put into the command line. You can look at my previous video where I demo this and see what that looks like when you actually call the fund multi, and that object will automatically be populated. So that is that is the only parameter that comes in. It's an array of the information we needed. Again, you can see the video or look at the data types. We're going through, we're calling using the Bitcoin node. We always connect to the Bitcoin node, and we're calling the estimate smart fee, which I probably want to move that to the internal lightning, but that's beside the point. That's where we are now, and I just want to show you what we have. We're going through and creating an estimate here is we need to have a fee rate to pass through to the command where we actually get the UTXOs, so we know how much value in UTXOs to get to. So we got to know how much are we going to spend and how much the fee is going to be. And we really don't know. It's kind of a chicken egg scenario until we actually get the UTXOs, how many we're going to need. So we're not going to know what the size is, but this is to give me a starting point. So I can go in and look and get my UTXOs based on a rough estimate. We find it tune it later on, as you'll see once we get to it. So we go and calculate the fee based on that. We go through and get the amount, the total up the amount for the recipients, and we want to make sure we have sufficient funds. We go through and get a change address. Well, let me back up. Let me go to the wallet interface. The wallet interface has three functions. UTXOs, which we need for building the transaction, a change address to make sure we get our money back, and we need to be able to sign transactions. So these three are part of our wallet interface. So that's where that's coming from. So let me go back. Okay, so we get our change address and the wallet. Before that, we look at the wallet type, which we got from our init command. If we had that option for the Bitcoin wallet, we would use the Bitcoin. If not, we use the internal wallet. So the Wally, using the generic interface, can call the change address, it can call the UTXOs, and it can sign the transactions. We just pass that along to it. So anyway, we loop through and make sure we have enough funds. If not, we error out and let the user know. And now we go through all our channels. And this is where we can go through and call the new RPC command, which I added here. It's now in the G Lightning, but I'm still using my own because I hadn't got to that refactoring yet. But it's going to call the fund channel start RPC command. And if anything happens, we're just going to bail out. Cancel multi is just a function that loops through down below here. Cancel multi. Just loops through everything we tried so far and says, no, sorry, no go. So we call the fund channel start. That gives us our address that we can use for the multiple outputs, for the multiple channels. So each channel has a multi-sig address, and the fund channel start will go, it has the information for the node you're trying to connect to. And you say, hey node, I want to start a channel, and it gives you, between you and it, a multi-sig address with both of your keys so that you have access to it. Once you have that address, then we can start, building transactions. We're looping through, so we're going to get all the addresses and then build a transaction. So let's see, we got the UTXO. If we don't have enough here, what are we doing? Okay. What we're trying to do is if we're within the dust limit, we don't need a change to use the change output, so we're not going to append it. We're going to check and make sure it's worthwhile to have a change, which usually you will. So we add that to the recipients. And then this is where, okay, now we know. I have some utility functions I added. The input fee sats and output fee sats. And I came up with this formula, which seems pretty accurate to give me the actual size that's going to be used for your, so if you have your fee rate, 2 Satoshis per byte or whatever, you know how many bytes you have at this point. So I can go and update the last recipient I pushed on was the change address. So down here I'm going to get that last recipient in this line, and I'm going to put in a more accurate fee. So now that I have that, I can call the wallet, create transaction, which we can take a look at that. Create transaction just loops through all your inputs. It adds them in, loops it through all your outputs, and it serializes that into bytes. Pretty straightforward. So back to my fun, create the transaction. Once we have that and no errors, we can sign it, which is implemented in the wallet. There's the Bitcoin version and the internal version, and they each do. We'll go into how that all works here shortly. But once I have that, I can serialize it and make it ready to broadcast. But first we want to loop through and call our fun channel complete RPC command. Once we have this the transaction built, then we have the transaction ID, and we know which output we're looking at. They're kind of in order now, but I've since updated this to actually look at the transaction and pull the outputs out. But it's simpler to show this way. I'll show the next one where I actually have that. We're looking through the transaction, and you can see the process of how I get from one step to the other. But right now it's just sequential, so V out is going to be whatever order it comes in. So you call the fun channel complete, and we're doing this beforehand, even though we don't have a transaction broadcast yet, because if something goes wrong, we want to bail out. We got the close multi here, which before we had a cancel multi, but close says, oh, because we already opened the channel at this point, we want to close it and never really do anything with it because no funds have been sent at this point. But this is important to do this beforehand, because if you tried to broadcast a transaction and you had an error here, well then you got your target address, which is a multi-sig between you and someone else, and that would be a problem. So we don't want that. We want to call this and then come down to our Bitcoin node and send the transaction. If we have an error there, well, there's still no transaction on chain, so we loop through and close out. And so we've done that all as well. We return something pretty to your console that shows you all the channel information, just like you would with the fun channel command, except for the only difference is we're showing all the channels. It would just show you one ID, and since we're doing multiple, we have an array that we return. So that's the difference between that and the fun channel. So let's look at wallets. We have the Bitcoin, and we have, let's see, the internal. Now these both, as we mentioned before, they implement the wallet interface, which allows them to get UTXOs, to get a change address, and to sign transactions. So that's a Bitcoin. Okay, we got two different we first have to create it. You can see the new Bitcoin wallet, new internal wallet. The Bitcoin wallet is going to call the RPC command list configs, which is the C Lightning command that will tell you some information about how you can connect to your Bitcoin node. Now we're always going to use a Bitcoin node, like I said, because that is how we broadcast the transaction. So we always use that even if you were using the internal wallet for spending. So we're going to go through and we're going to use the results from the list configs command, and if we find a usable match, here or here in those lines, we're going to have enough information to where we can connect to it. I have it hard coded to localhost, but that's a good starting point anyway for now. If not, if we can't get it from the list configs, because there's two different C Lightning operation modes. If you actually have a config file for your Lightning, or if you pass your Bitcoin user and password and that information on the command line, it will show up in the list configs. If you're using more of a default configuration, it knows where to find it, and it doesn't bother listing it in the configs. But as a fallback, we can go, use your home directory, the Bitcoin config, and we're going to look and read information from there and look for our RPC user, RPC password, host port, all the information we need to connect to the Bitcoin node through the RPC. So That's pretty much it. We have a Bitcoin wallet structure which has pretty much everything we need to connect to it. The internal wallet, we kind of need, like what I showed you in the last video, how to get information from the secret to get your keys. So I'm not going to go through that again. But we get that initialized to where we have our master. We have our the lightning. These are all internal variables. You notice the lowercase. The lightning is for your RPC commands. The net is which network we're on, if we're on RegTest or we're on testnet, or if we're on the main net, which is needed for signing. And the directory for some other calls. I don't remember quite specifically, but anyway. So let's go over the interface here. We have UTXOs for Bitcoin. And let's look at UTXOs for the internal wallet. It's basically the same process. We get a list of UTXOs and we loop through them based on the amount and the fee. We pick one out as suitable for it. The Bitcoin, we're calling the list unspent RPC command. Here we're doing a database query to get the information. Some of this could be done through the RPC command, but there's some information that is only in the database, so I decided to go with the database here, like script hub key, which is handy later on for one, you can derive the address from it. And so I went that route using the database query. They start getting similar once you get into the loop. Now you can see this is looping through rows of the database for the internal, whereas here we're just, looping through the results of the list unspent. And I'm actually doing a compare for min configs, but I should probably just add that to the list unspent command. So basically looping through, and if we find something that's within the dust limit, well, that's going to be our best case to where we don't need to change address. We have less output, so we have a cheaper transaction. So, and if we don't find anything that way, which is a more likely case, we're going to loop through again and see if we can find multiple candidates. These are both sorted. The internal is sorted via the database query. The Bitcoin is sorted via this what I set up here. So, and calling the sort by amount, that type. So we have sorted. So if we loop, you can see I'm looping on both on a negative direction. So I'm going to get the least amount possible since I'm starting with the highest value first. So there's probably better coin selection algorithms than this, but that's what I came up with. I probably want to refactor that out too, so I can just get to a common format, do the coin selection externally, and just do it the same way every time. Just with right now I have different data types because the database query gives me one and the list unspent gives me another. So this was the quickest way, but not very elegant. So refactoring it is in order here. But everything with time. This is my ready, fire, aim programming approach. So this is what I got for now. So once we have that, we go and store everything in a way that we can use it in a return value of this UTXO type, which at that point does become a common value. Once I refactor it, maybe it'll be a common value first, and then, but anyway, that's where we are. So that's one. Change address is pretty simple on both of them. It's just an RPC command. Change address in Bitcoin, calling the get raw change address. We're always, we're SegWit friendly here. We want to always use the Bec32. And Lightning, we're calling the Lightning RPC. They don't have a distinction between change address and receiving address, so we just get a new address there. Now the signing, gets a little more interesting for the internal wallet. For the Bitcoin wallet over here, it's pretty straightforward because we already have the inputs in the UTXO set, and we just loop through and call the dump-proof key, which will give us all the private keys for the UTXOs that we're spending, and we save that into an array, which we pass as to the sign raw transaction. As long as we have all the keys, which we will at this point, you know, we just call the sign raw transaction with key RPC function, and that way we have a signed transaction. So we're good to go there. With the internal wallet, it's a little bit more tricky. What we have is they have the outputs stored in the database, the outputs that are available for spending, and everything is by a key index. So the key index is which child are we deriving from. Remember earlier in the last video how we got the private key for the derivation. So when we do this query, we have to get this key index. And once we have that, and we already have our master from before, from when we first started up, we can derive a child from that. So that's how we get our private keys for the internal wallet. We derive them on the fly based on what we got from the database query. So we're going to do a similar, we're going to loop through, we're going to get the private key, and we're going to sign down here. Now this works great if you're using the BEC32, but if you're using the P2SH, which the internal wallet supports at 2 different types, there's this extra little step you have to go through here and supply the script pub key input to the input itself as the hash of the public key. So that's an extra step. That's the way the P2SH works. So, but either way, we come down here, we do our signing, and after we loop through, we set the sign value on the transaction to a signed transaction. What I'm doing is starting with a partial, which is the unsigned, and I'm just tracking that. It's partial as long as it's, you know, being signed by some of the inputs. Once it's signed by all the inputs, well, then it's not partial anymore, it's complete. But so once that's set, and here on the Bitcoin side, we're doing the same thing, you know, setting that to signed. So if I go back to my fund, we call the Wally sign, and once we have a signed transaction, we're good to go. We already went through all this. We do the fund channel complete and send TX, but that's where what I just showed you come in, the sign of the transaction. So let's see, is there anything else we need to go over here? I think that's pretty much, oh, the withdrawal I added, which is basically very similar to the funding, except for you don't mess with all the channels. So it's a lot more simpler. We come and get our fee rate. We're always using the internal wallet. It wouldn't make sense to do a multi-channel wallet with a Bitcoin wallet. I think that is already built into it. But it's a feature that was asked for the Sea Lightning. So I added it here. It's the same process. You go through and, you know, get your UTXOs, you get your change address, you loop through all your addresses that you want to send to. You go through and you come down and sign it once you got the transaction built. You create a transaction, sign it. And here we don't have to worry about all the channels. We can just go and send it once it's signed. And, you know, if we fail, well, no funds lost, they're still in your wallet. So, and we return a similar to the withdrawal, we got the actual full transaction that we sent and the TX ID. So that's like the withdrawal, but with multiple channels. So that's pretty much it. I have, like I said, I've done some refactoring to allow this to work with a client server where you can have multiple users coming together. And I'm just getting started with that, but I can show you before we get into that, before that's complete, the refactored out version in an upcoming video. So there you go.